In a velocity time graph or a speed time graph, the gradient of a line is the acceleration, and the area under the graph is the distance traveled. Let's look at an example. Here we've got a velocity time graph for a train journey between two stations. Find the distance traveled by the train. So the distance traveled is the area under the graph. So the distance traveled is the area under the graph. So we could either calculate the area of the triangle, the rectangle, and the triangle and add them together, or we could use the area of a trapezium. Either way, let's do the triangle, rectangle, triangle. So the area of a triangle is half times base times height. So half times 20 times 40 for this first triangle. Half times 20 times 40. Half of 20 is 10. 10 times 40 is 400. For the rectangle, it's 80. Its length's 80. Its width's 40. So 80 times 40. 8 fours are 32, plus the 2 zeros, 3,200. And the last triangle, we've got half of 15 times 40. So half of 40 is 20, and 20 15s is going to be 300. So 2 15s are 30 times 10, 300. So the total distance is 400 meters plus 3,200 meters plus 300 meters. So what do we have in total? That's 3,900 meters. We know it's in meters because our velocity was in meters per second. Part B says find the rate of acceleration of the train in the first 20 seconds. So to do that, we're working out the gradient of this line. The gradient is the change in y. So acceleration is gradient, and gradient is change in y over change in x. Or in this context, it's the change in velocity over the change in time. So it's 40 over 20, which is 2. And the units for acceleration are meters per second, or meters per second squared. Okay, one for you to try. So give this a go. So again, we've got a velocity time graph. Part A says find the distance traveled. So the area under the graph. So we've got a trapezium and a rectangle. So the area of a trapezium is half the sum of the parallel sides. So half of 4 plus 10 times the distance between them, which is 5. So 4 and 10 make 14. Half of that is 7. 7 fives are 35. And the rectangle, it's got a base of 15, a height of 10. So 15 times 10 is 150. So 35 plus 150 is 185, and it's in meters. So 185 meters. Find the acceleration in the first. Find the acceleration in the first 5 seconds. So it's the gradient of this line. So it's the change in y over the change in x, or the change in velocity over the change in time. So how much has it gone up? It's gone up 6. And it's gone across 5. So it's 6 over 5. Or, that's a perfectly good answer actually, or 1.2. meters per second, or meters per second squared. Here we have another example. It's a velocity time graph for a car journey, and you can see we've got a curved graph this time. So we haven't got straight lines, and that means we're going to be estimating the acceleration. So estimating the acceleration and estimating the distance traveled. We're not going to work it out exactly. We're going to use estimates. So part A, estimate the car's acceleration when t equals 2. The acceleration on a velocity time graph is the gradient, and we estimate the gradient at a certain point by drawing a tangent. So if I draw a tangent, so it's going to be a line that just touches the curve at that point, and work out the gradient of the tangent, we can use that as an estimate for the gradient at that point. So let's work out the change in y over the change in x for this line. For every one it goes across, how much does it go up or down? So let's look at finding a good point. So we're going to say it's going through 2 and 12.5. And 5 and 22. So it's going along 3 here, along 3, and from 12.5 to 22 is 9.5. So for every one it goes across, how much does it go up? So if we do 9.5 over 3, so that is 9.5 over 3. So I'll just double top and bottom and write 19 over 6. So that is 3 whole ones and 1/6, or I can just write 19 and 1/6. I'll put 3 and 1/6, and it is in its acceleration, and it's meters per second over seconds, so meters per second, or meters per second squared. It is an estimate, so from the same graph I could have drawn a slightly different tangent, and I could have got a slightly different answer. There'll be a range of acceptable answers for a question like this. Part B, estimate the distance traveled by the car. So that's the area under the graph. Use 5 strips of equal width. So if I get rid of this, so I'm going to split this graph up into shapes that I can work out the area of. So I'm going to do 5 strips, so 0 to 2, 2 to 4, 4 to 6, 6 to 8, and 8 to 10. So I'm going to have a triangle for my first shape. Then I'm going to have trapeziums. So I'm going to have 1 triangle and 4 trapeziums. So I'm going to work out the area of each of these shapes and add them together to get an estimate for the distance traveled. So for the triangle, the area of a triangle is half times the base times the height. So that's half times 2 times 12.5. Half of 2 is 1, so that's 12.5. For a trapezium, we're going to do half the sum of the parallel sides. So half of 12.5 plus 17 times the distance between them, which is 2. So that's going to be, well, half and 2 are going to cancel out. So 12.5 and 17 make 29.5. Then the next one, so half of 17 plus 20, half the sum of the parallel sides times the distance between them. Again, the half and the 2 are going to cancel out, so 17 and 20 make 37. I've got 20 and 22. So that's going to be 42 meters. And I've got 22 and 23, which is going to be 45 meters. So I've got all my 12.5 meters, 29.5 meters, 37 meters, 42 meters, and 45 meters. So if I add all of these together, I will get my estimate for the total distance. So 45, 42, 37, 29.5, and 12.5. So 5 and 5 make 10. I've got 9 plus 1, which is 10, plus 2, so 12, 19, 21, 26. And I've got 2, 3, 4, 5, 6, 7, 8, plus 8. So it's 166 meters. So my estimate for the total distance traveled is 166 meters. And you can see that's probably slightly lower than the actual distance traveled because I've missed out this green section. So it's probably an underestimate of the total distance the car actually traveled. Okay, one for you to try. So give this one a go. So again, we've got a curve for a car journey, and we're being asked to estimate the acceleration when t equals 10. So we do that by drawing a tangent. So we draw a tangent that just touches the graph when the time is 10. So something like that. And we are looking hopefully for some good points. So let's say 16 and 37 here. And 6 and 24 there. So from 6 to 16, that's along 10. And from 24 to 37, so 24 to 37 is 13. So I've said change in y is 37 minus 24 over the change in x, 16 minus 6. So that's 13 over 10, which is 1.3 meters per second meters per second squared. Part B, estimate the distance traveled. Use 4 strips of equal width. So I'll clear off this working. So we're splitting it into 4 shapes. So we're going to have a triangle, and then 3 trapeziums. So the area of a triangle is half times base times height. So half times 5 times 20. So 5 times 20 is 100. Half of that is 50. For the trapezium, we're going to do half the sum of the parallel sides. So half of 20 plus 29 times the distance between them, which is 5. So 20 and 29 make 49. So half times 49 times 5. So half of 49 is 24.5. 24.5 times 5. 24.5 times 10 is 245. So half of 245 is, so 245 over 2 is 122.5. The next one, we've got 29 and 34. So half of 29 plus 34 times 5. 29 and 34 makes 63. Half of 63 is 31.5. So 31.5 times 10 is 315. Half of that is 157.5. And then we've got 29 and, no, we've done that one. So it's 34 and 36. So half of 34 plus 36 times 5. So 34 and 36 makes 70. So it's 35 times 5, which is 175. So we've got 50 meters, 122.5 meters, 157.5 meters, and 175 meters. Let's add them all up. So 122.5 plus 157.5. That should be a nice round number. So that would be 280. So 280 plus the 50 will be 330 plus the 175. So 330 and 170 make 500 plus the extra 5. So we've got 505 meters. We could have probably done with a calculator for that question, but it's good to practice. And to finish up, one more question. So again, this time it says speed time graph, but we're going to answer it in exactly the same way. So estimate the car's acceleration when t is 5. That means draw a tangent at t is 5. And we're going to work out the gradient of this tangent. So let's pick a good point or two good points. So we've got 0, 15. And where's a good point? It looks like we've got 11, 30. So the gradient is going to be the change in y, or the change in speed, over the change in x, or the change in time. So it's 30 minus 15 over 11 minus 0. So it's 15 over 11, which, well, we can't really simplify that. So 1 whole 1 and 4/11ths, and that's in meters per second per second. meters per second squared. Estimate the distance travelled by the car using 4 strips of equal width. So we're going to have a triangle. So a triangle and 3 trapeziums. So the area of a triangle, half times base times height. So half times 5 times 22. Half of 22 is 11. 11 fives are 55. For the trapezium, we've got half the sum of the parallel sides. So half of 22 plus 25 times the distance between them, which is 5. So 22 and 25 make 47. Half of 47 is 23.5. And half of, 23.5 times 5. So half of 235, which is 117.5. Then we've got the next trapezium. So half of 25 plus 28 times the distance between them, which is 5 again. 25 and 28 make 53. Half of 53 is 26.5. So 26.5 times 5. So 26.5 times 10 is 265. So half of 265 is 132.5. And the last one, we've got 28 and 40. So half of 28 plus 40 times 5. 28 and 40 makes 68. Half of 68 times 5, so 34 times 5. So half of 34 times 10 is 340. Half of that is 170. So there are 4 areas. If we add them all together, so 117.5 plus 132.5 makes 250. 250 and 170 make 420 plus 55, so that's 475 meters.